Hello everyone. In this video, we're going to focus on hyperbolas. Please remember that there are two cases of hyperbola. First is the horizontal hyperbola and the vertical hyperbola. Now let's go over each of these cases. Let's go over the first case here, horizontal hyperbola. We call this as horizontal hyperbola because the hyperbola opens to the left and it opens to the right. And at the same time, its transverse axis is the horizontal axis. Now, these are the parts of the horizontal hyperbola. First, we have the vertex, and there are two of them. These are the two vertices. We have the center, and then we also have an asymptote. An asymptote, again, is a line. In this case right here, it's a line where this hyperbola gets closer and closer to it, but it's not going to touch it. We also remember that there are two foci of a hyperbola. So these two right here are the two foci. We also remember that our center, which is represented here as letter O, is actually having a coordinate of HK every time. So that is represented as HK. And then the distance from the center to the vertex is represented as variable A. So I'm just going to go ahead and label this as A. Again, that is the distance from the center to the vertex, and the distance from the center to the focus, one of the foci here, this is represented as letter C. And we also remember that the distance from the center to the co-vertex. So this point right here is called co-vertex, and this is the vertex. So there are two co-vertices, and these two co-vertices are located along the conjugate axis. So this is our co-vertex. The distance from the co-vertex to the center is represented as letter B. Now, we can go ahead and write the equation of this horizontal hyperbola, and this is represented as x minus h squared, that is over a squared, minus quantity y minus k squared over b squared is equal to 1. This is the standard form of a horizontal hyperbola. So I'm just going to put this inside the box. So this is the equation for the horizontal hyperbola. Now, we also remember that the equation of the asymptote for horizontal hyperbola is y equals k plus minus b over a quantity x minus h. So the reason why it has a plus and minus, it's because this is the plus part and this is the minus part. So this is the equation of the asymptote. So I'm just going to go ahead and label that up here. Now let's go over the second case of hyperbola. The second case of hyperbola is labeled here as the vertical hyperbola. This is a type of hyperbola where it opens up and the other end opens down. So we can say that this is vertical hyperbola because its transverse axis is the vertical line. So in this picture right here, we have here the vertex. That's the first vertex, and this is the other vertex. So these are the two vertices of this vertical hyperbola. And we also have the center right here. We remember that the center is represented as HK. And we also have the conjugate axis. So the conjugate axis is the horizontal axis. Are the two asymptotes. We remember that an asymptote in this case is a line where the hyperbola gets closer and closer to it, but it's not going to touch it. Now, we also have the two foci here. So these are the two foci. We also remember that the distance, it's the same thing with the horizontal hyperbola. The distance from the center all the way to the vertex is represented as variable A, while the distance from the center all the way to the focus is represented as letter C. Now the distance from the center all the way to the co-vertex. By the way, there are two co-vertices here. So that's this is the first co-vertex. This is the second co-vertex. The distance from the center to the co-vertex is represented as letter B. So that we can go ahead and write the equation for the vertical hyperbola. So this is the equation for vertical hyperbola. We also remember that the equation for the asymptote of a vertical hyperbola is represented below. To better understand these two cases of hyperbola, let's go over some examples. In this example, we're supposed to sketch the graph of the given equation below, and we're supposed to determine the center, the transverse axis, the conjugate axis, the vertices, the foci, and the equation of the asymptotes. So just by looking at this, we can tell that this is not in standard form, because remember, this one has to be 1. So what are we going to do here is that we are going to divide both sides by 225. So I'm just going to go ahead and show the work up here. Okay, so we already have this equation. So what I did was I divided it by 225 to make this right side of the equation equal to 1. Now, what are we going to do is we are going to reduce this to lowest term, the 36 and 225, so that we can go ahead and rewrite this as y squared over, that's going to be 6.25, and then that is minus x squared over 2.25 is equal to 1. So as you can see, this is already in standard form. So that we can go ahead and say that from this given equation, our a squared is 6.25. So I can go ahead and write that down here. So that is a squared is 6.25. So then our a value is the square root of 6.25, which is 2.5. And then our b squared is this one right here. So that is 2.25. So that we can go ahead and say that our b is the square root of 2.25, which is 1.5. From here, we can go ahead and say that given this equation right here, our h and k is 0. This tells us that the center of this hyperbola is at 0, 0. So I'm just going to go ahead and write it down here. Okay, so then we can go ahead and label that on the graph. We have the information that we have up here. So our center is at 0, 0. So I will write that up here. So looking at this equation right here, this is an example of a vertical hyperbola. So that we can go ahead and say that our transverse axis, our TA, is actually the vertical axis, while our conjugate axis, I'm just going to go ahead and write an acronym for that. So conjugate axis would be the horizontal axis. So again, I would like to repeat that TA stands for, in this case right here, is the transverse axis, which is the vertical axis, while the conjugate axis is the horizontal axis. Since our vertical axis is the transverse axis, we can therefore say that our A is sitting along the y-axis. So from the center of the hyperbola, we go up 2.5 and down 2.5. So because again, the vertical axis was the transverse axis. So 1, 2, 2.5, and then go down 1, 2, 2.5. And then looking at the B value, the B is the distance from the center to the co-vertices. And the co-vertices for this hyperbola right here is sitting at the conjugate axis. So that would be 1.5 for left and right. So 1, 1.5. And then 1.5 is going to sit right here, so that we can go ahead and draw the rectangle. Now, please remember that the purpose of writing the rectangle is that it will help us draw the hyperbola later on, so that we can go ahead and draw the hyperbola more accurately. we can go ahead and draw the diagonals here. Okay, so we can go ahead and draw the hyperbola. So the hyperbola is opening up and down, since this is an example of a vertical hyperbola. So we can go ahead and draw that first branch up here. Now we remember that this hyperbola is going to get closer and closer to the asymptote, but it's not gonna touch it. It's gonna get again closer and closer to the asymptote, but it's not gonna touch it. And it's gonna be the same thing for the other side. So it's gonna get closer and closer to the asymptote, but it's not gonna touch it. So this is the graph of this hyperbola equation that we have up there. Now we go ahead and determine the location of the two foci. Now we remember that the focus is located c distance from the center, so that we can go ahead and solve for the c value. So I'm just going to go ahead and show the work up here. So the formula for the c of a hyperbola is c squared is equal to a squared plus b squared. Now we plug the values in. Our a is squared is 6.25, so that is 6.25 plus the b squared is 2.25. Adding them together, this will come out 8.5, and this is again our c squared. So solving for c, we're going to square root both sides. So this comes out c is equal to the value of the positive and negative square root of 8.5, or this is approximately 2.9. So I'm just going to go ahead and write that down there. So we can go ahead and say that our focus is located 2.9 up, 2.9 down. So that's 1, 2, 2.5, 2.9 is somewhere here before the 3. 2.9 is somewhere here before the 3. So this is our focus and this is our focus. So that we can go ahead and determine the vertices. So the two vertices are these two right here. So we can go ahead and write that up here. So the location of the two vertices are at 0, 2.5 and 0, negative 2.5. Now let's look at the location of the two foci. So it's up here and this foci right here. So the coordinate of these two foci would be, so these are the coordinates of the two foci. Now let's determine the equation of the asymptote. So these two asymptotes right here. We remember that the general equation for the asymptote whenever we get a vertical hyperbola is that we have y equals k plus minus a over b quantity x minus h. Now we know that our center is at 0, 0, so the hk value would be 0. So that is y is equal to 0 plus minus our a value is 2.5. So I write 2.5 over the b is 1.5 quantity x minus 0. So that we can go ahead and say that the equation comes out to be that's going to be plus minus 2.5 over 1.5x. Now, if we simplify this, this would come out y equals 5 over 3x, and the other asymptote would be y equals negative 5 over 3x. So these are the equations of the two asymptotes. So the negative asymptote represents this, while the positive asymptote represents this one. So we can go ahead and label the equation of their asymptotes. Now let's move on to the next example. So in this example, we're supposed to sketch the graph of the given hyperbola below, and we determine the center, the transverse axis, the conjugate axis, the vertices, the foci, and the equation of the asymptote. So that we can go ahead and divide both sides by 225 so that we can get 1 on the right side of the equation. So I'm just going to show the work up here. Okay, so this is the standard form of this given hyperbola. Now we can tell that our center is at 0, 0. So I'm just going to go ahead and write that up here. So the center for this is at 0, 0. Now we can go ahead and say that this is our A and this is our B. So that we can go ahead and write that down here. Okay, looking at this equation that we have here, we can tell that this is an example of a horizontal hyperbola. Therefore, we can go ahead and say that the transverse axis is the horizontal axis and the conjugate axis is the vertical axis. I'm just going to go ahead and write that down here. Okay, so then we are ready to sketch the graph. Again, our center is at 0, 0. So I put the center right there. And our transverse axis is the horizontal axis, and in this axis, this is where our vertex is going to sit, and that would be 2.5 units away from the center. So that's 1, 2, 2.5, and then we also have 1, 2, 2.5. So these are the two vertices, and then we also have the B value is 1.5. So this is going to sit on the conjugate axis, which is the vertical axis. So that's 1.5, 1, 1.5, and that is 1, 1.5. Again, this is our co-vertex, and this is our co-vertex. So we're now ready to sketch the rectangle. Again, the rectangle is going to help us draw the hyperbola. So we draw the rectangle up here that covers the 4 points. And then from here, we can draw the asymptote. Since this is an example of a horizontal hyperbola, we can go ahead and say that it opens left and right. So we can draw the first branch of the hyperbola on this left side here and the second branch right here. And this is the other branch as well up here. So this is the graph of this hyperbola in standard form, so that we can go ahead and determine the location of the focus. So that we go ahead and solve for C. I will show the work on the side here. So the focus is located 2.9 away from the center, left and right. So that is 1, 2, that's 3, 2.9 should be somewhere here. So we can have this as our focus, and this is the other focus on the other side here. So that we can go ahead and write the coordinates of the vertices and the two foci. Okay, now we're ready to determine the equation of the asymptote. In order that we can determine the equation of the asymptote of this hyperbola that we have here, the general equation for the asymptote for horizontal hyperbola is y equals k plus minus b over a x minus h. So I plugged in the value. Our k and h would be 0. Our b is 1.5 and our a is 2.5. So in this graph, this asymptote is actually the negative. So y equals negative 3 over 5x. And this asymptote right here is the positive, y equals 3 over 5x. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!